right, class. You guys are here. I got myself a new pen. Let's wait a couple more minutes while I enjoy my Diet Coke. I'm gonna make the exam available tomorrow, and we'll make the exam due Friday. So good. And I'm having authentic Chinese food known as Panda Express. Hmm. All right. Let's look at the first word problem. You are designing a rectangular poster to contain 72 square inches of printing with a 2-inch margin at the top and bottom, and 1-inch margin at each side. What overall dimensions will minimize the amount of paper used. So this is a hard one. All right, I want you to read the problem and try to draw it before we attempt it. Try it. All right, try to draw the poster. Try to visualize it, what's happening. So if I draw this out, here's my poster. On the side, it will have 1 inches, and on the top, I have one. Why is it so big? Oh, that's fine. Let's do 1 inch, and over there 2 inches, and then Inside you have 72 square inches. And we want to know the dimension. Well, we know one thing, that the length and the width, they're proportional, right? So if I say length times width is 72, and we say, let's say length is X, then W would be what? 72 over X, which equals 72. You guys get that? That's the hardest part of this argument. Without it, you won't be able to get it anywhere, because we know the area is 72 square inches, length and width times 72, and they're proportional. So if length is X, then width must be 72 over X. Okay, so let's set it up. So what's the actual dimension of the poster? All right, let's look at, if L equals, let me make it bigger now. If L equals X, width equals what? 72 over X, right? Now what's this total width? For the poster, it will be 72 over X plus 1, which is 72 over X plus 2. And then what about the height? Or yeah, let's use the height or length, whatever it is. In this case, it will be X plus 2 plus 2, which is X plus 4, which we're talking about this part. That's H. So what's the area of the poster? Area would be 72 over X plus 2 times X plus 4. And just to save time, I just multiplied it out, and I get 2X plus 288 over X plus 80. All right. And we want to maximize the area. So what if we look at the derivative of it? It will be 2 minus 288 over X squared. You set it equal to 0. And you solve for it. You get what? 288 over X squared equal 2. So therefore X equals negative 12 and positive 12. Well, we can't use that number. So let's use X is 12. Let X be 12. Then what's the actual width would be? 72 over 12 plus 2 gives me 8 inches. And the height would be 12 plus 4, which is 16 inches. So the dimension would be 16 inches by 12 inches. That was a hard one. Any question, guys? I'm not gonna give you any volume questions, such as like if you get cone inside a sphere. I'm not gonna give you that type of question on the test. All right, let's do. Ooh, this is a good one. Let's do this one. And all right. A covered box is to be made from a rectangular sheet of cardboard measuring 50 inches by 80 inches. This is done by cutting out the shaded regions of the figure and then folding on the dotted lines. I'm gonna give you that. It's like, have you ever seen the pizza box? That's what it is. We're literally making pizza box. What are the dimensions x, y, and z that maximize the volume? All right, so let me draw this out. Yeah. Has anyone ever worked in a pizza place before? When I was young, I applied at a pizza place. I was never hired. My first job was at Wiener Schnitzel. I would drop hot dogs on the floor and I would not throw them out. We just cooked them over 180 degree and that was good enough. Like, it kills every bacteria, anything like the salmonella, anything you can think about. So these are the X they're talking about. So when you cut out the corner, it kind of lifts up. That's your Y. And your Z would be this right over here. Okay. Now I want you to try that problem. Try that problem. All right, try to attempt the problem, class. Before I do it, this is a hard one. I want you to get stuck first while I drink on this amazing Diet Coke by Coca-Cola. Especially when you exercise, you must drink Coke. I'm kidding, guys. Don't quote me on it. I'm giving you all bad advices. Couple more minutes, class. Okay, so I've given you enough time. Let's look at it. So first thing first. So the way we find the volume. Oops, sorry. Let's use that. Volume would be x. Oh, it's too big. X times y times z. And x must be greater than 0 but less than 25, because we're talking about measuring inches 50 by 80 inches, right? So we're talking about 50 by 80 inches, and this x cannot be greater than 25, because if it's greater than 25, then then you don't have the dimension happening. So let's look at it. So let's write it. Express y and z in terms of x. So y equals 40 minus x, and z equals 50 minus 2x. Okay? So the volume in this case would be x times 40 minus x, 50 minus 2x. All right? Because we said that this is 50 and this is 80, and we're talking about half of it. Okay? All right. Now, let's simplify it. I'm just gonna, I did the problem early on, so we're just gonna do it. I gave you some time to do it. Uh, uh, if you have question, ask me the question right now. So and we want to maximize the volume in this case. When we take the derivative of it, you get 6x squared minus 260x plus 2000. And we set that equal to 0. And then we solve for x, 2000. And since it's quadratic equations, x is going to be, you'll get 3x minus 100, x minus x minus 10 equals 0. So the critical points are 100 over 3 and 10. And that's what we need to work on right now. Uh-oh. I'm mixing up my pages. So if we say let x be 100 over 3, do you see what's the problem we have? We have a domain problem. This number is outside the domain. No, here's another way. Let me write it down. Notice at the endpoints, notice at the endpoints of the interval, and it needs to be in that, and 100 over 3 is outside that. So we have left with left with x is 10, and the moment we have x is 10, y is 30, and z is 30, and that's the dimension. Okay, so this is it. You will have the exam opened up. I give you extra time on this section because this is one of the hardest ones to deal with it. If you have questions, ask me right now. I'll be by my computer.